Okay, in this chapter, we will learn about how the structure of a substance will affect the properties of that substance. So first, in this world, we can simply classify substance into four structures. The first structure is simple molecular structure. It involves all covalent substances, except a few with giant covalent structure. Okay. For giant ionic structure, it involves all ionic compounds. For giant covalent structure, in DSC, you just need to memorize three substances: graphite, diamond, which both of them are carbon, and also silicon dioxide. If you are bright enough, you may also memorize silicon to be giant covalent structure. So except these four, the other covalent substances will be simple molecular structures. So for all metals, it will be giant metallic structure. In this video, I will try to explain those properties of the structure a bit, and then we will discuss in more details during the lessons. Okay, this these kind of questions are quite common in DSC. Okay, I want to show you how we can get the marks in the exam rather than know how to explain only. Using iodine as an example, iodine have the formula of I2. So each iodine molecule would be formed by two iodine atoms. So in between the iodine, there will be a strong covalent bond, which is very difficult to break. But between the two iodine molecules here, alright, it is held only by the weak intermolecular forces. Okay, so that is very important to explain why most of the properties of iodines. So two iodine atoms are covalently bonded to form a diatomic molecules, which means the molecule is composed of two atoms. So the molecules are packed in a regular pattern, but they are still discrete molecules. Discrete molecules means that the two molecules, although they are held together by the weak intermolecular forces, but they can be easily broken down into pieces. For the properties, since the iodine molecules is non-charged, so that's why there are no charge carrier or some charged substance responsible to conduct the electricity. So that's why they are non-conductors mostly. There is a slightly soluble in water only. We will explain it later. The most unique characteristic of simple molecular structures is they all have the low melting point and boiling point. Alright, this is we will explain it later. And then they will be salts. For iodine, it also undergoes sublimation, but it is not for all simple molecular structure. What you should focus is these four properties. Well, you will also see these four properties afterwards when we discuss other structures, like whether the structure conducts electricity, whether it dissolves in water, whether it has low or high melting points, whether it is soft or hard. When you put some iodine into the water, only very few of them will dissolve into the water. So you will see most of the iodine solids are sink to the bottom, and some of them dissolve to give the very light brown color here. Right? But for heptane, which is a non-polar solvent, it dissolves iodine much better than water. And you need to memorize that the color is violet, sorry. So let me explain more why simple molecular structure have low melting point and boiling point. But before that, we need to revisit what is the definition of boiling point and melting point. So in Form 1, you have learned that particles in solids are packed closely in a fixed position. Liquids are a little bit looser, and gases, they can free to move. Okay, so that is in particle theory. And also particles are attracted to each other with different types of forces. Like in simple molecular structure, all the particles are attracted by weak intermolecular forces. So when the solid is melted, it talks about, melting point talks about the temperature at which solid turns into liquid. So for boiling, it is the temperature, boiling point is the temperature at which liquids turn into gases. And you know, temperature is a measure of average kinetic energy of the particles. The higher the temperature, the higher the Ke of the particles it is. So at melting points, that is a very important concept. At melting points, the Ke of the particles is enough for all particles to break part of the attractions in between, so that the particles are free to move in certain extent. That means becomes less patted in liquids. So at boiling points, the Ke of particles is enough for all. Okay, it must be for all particles to break the attractions in between completely, so that the particles are free to move now. So for the sublimation of iodine, okay, sublimation point is 183 degrees Celsius, which is a lot lower than those giant ionic structures. So in order to separate the molecules of iodine so that they can move freely, what we need to break is the weak intermolecular force. Okay, the strong covalent bond in between is not broken. So that's why when temperature increases, particles will vibrate more vigorously and break the attraction between particles. In this case, intermolecular force is weakened instead of the strong covalent bond, and therefore the particles can move freely as a gas. And since the intermolecular force is a lot weaker than those strong chemical bonds, so that's why the energy required, that is the temperature indicated, should be a lot slower than those in giant ionic structures.